When water flows across a landscape, it hollows out a channel. The longer it runs, the deeper that pathway becomes, eventually forcing the water into a single, predictable route. Human behavior follows this same physical principle. Choices that begin as deliberate actions eventually solidify into icy tracks of automatic response. The psychologist William James recognized this in 1899, observing that our lives are composed of these unthinking choices and invisible decisions. Most daily actions and corporate strategies result from automaticity, bypassing rational choice. While we assume we are navigating the world through calculation, we are largely executing pre-programmed routines. This is a biological necessity. To conserve energy, the brain must convert complex sequences of actions into repeating loops. This allows the cognitive system to power down and save effort for unexpected tasks. This mechanical drive for efficiency dictates individual neural pathways, our corporate hierarchies, and the expansion of societal movements. Mapping this scalable architecture reveals how behavior is constructed. Once we can see the mechanical gears of these entrenched systems, we gain the ability to reprogram them. This cross-section highlights the basal ganglia, a specialized region near the brainstem. It serves as the neurological factory where active decisions are converted into automatic routines. To save processing power, the brain utilizes a process called chunking. It groups a sequence of actions, like backing out of a driveway, into a single unbroken unit. This allows the conscious mind to disengage from the mechanical details. These are data points from rats learning to navigate a T-shaped maze at MIT. During the first few runs, brainwaves spike up and stay elevated. Every smell and sound is being actively processed by a brain working at maximum capacity. Once the route becomes a habit, the graph transforms. Activity in the middle of the run drops to near zero. The brain is no longer thinking. It only spikes at the very beginning to trigger the habit and at the very end to process the result. This structure is the habit loop. The first spike is the cue, a trigger initiating automatic mode. The low-energy middle is the routine, the behavior itself. The final spike is the reward, which tells the brain that this specific loop is worth remembering. Habits become permanent through a neurochemical shift in the craving brain. Over time, the dopamine spike originally associated with the reward begins to fire earlier, arriving the moment the cue is registered. This anticipatory spike creates a neurological craving. The brain expects the reward before the behavior even begins. This craving provides the power that locks the habit loop into place. Because these pathways are physically etched into the basal ganglia, habits cannot be deleted or erased. Reprogramming behavior requires working within the existing architecture. To change a habit, you must keep the old cue and provide the old reward, but engineer a completely new routine to bridge the two. Behavior modification is a mechanical engineering problem. Success depends on identifying cues and cravings and replacing the routine node, rather than relying on moral willpower. The three-part loop functions within a single brain and operates identically across a multinational corporate entity. As the system scales, these loops dictate thousands. Within complex organizations, certain routines carry disproportionate weight. These are keystone habits, the central gears connected to dozens of smaller, secondary processes. Shifting a single keystone habit acts as a mechanical lever. Changing the central routine dislodges and remakes the adjacent cultural patterns across the entire firm. Executive Paul O'Neill used this lever to transform the aluminum manufacturer Alcoa. He ignored financial metrics and focused entirely on a keystone habit of worker safety. Optimizing for safety required a total restructuring of Alcoa's industrial infrastructure. To meet safety goals, the company had to flatten communication hierarchies and redesign manufacturing floors. These changes eliminated production bottlenecks, causing costs to plummet and profits to reach record highs. The evolutionary economic theory of Richard Nelson and Sidney Winter explains why these habits are so deeply rooted. Nelson and Winter argued that firms do not use rational decision trees. Instead, they rely on rigid institutional habits established over the firm's history. These institutional habits serve as a truce. In any large organization, rival factions compete for power and resources. The truce is a rigid, agreed-upon routine that prevents internal conflict and maintains operational equilibrium. Because these truces are foundational to survival, they typically only yield to change during a catastrophic crisis, which forces factions to negotiate new routines. Predictive analytics allow companies to bypass the need for a crisis by identifying moments when individual habits are naturally vulnerable. Retail corporations like Target track consumer data to exploit major life changes. By identifying when a shopper's rigid truces are broken, such as during a pregnancy, the company can intervene with new cues and rewrite their shopping routines. Corporate strategy is the management of an ecosystem of truces and keystone habits. Lasting organizational change requires the deliberate disruption of these entrenched patterns. Shifting from corporate truces to mass societal movements requires a different scale, the macro-sociology of network topology. This sociogram displays the sociological architecture required to scale a behavioral habit across a massive population. Social movements ignite within strong ties, the dense clusters of family and close friends. Because trust is high, these groups provide the initial localized spark required to initiate a new routine. To scale across a society, the habit must travel across weak ties. These connections act as bridges between isolated clusters, utilizing peer pressure and community standards to transform a local routine into a societal norm. The Montgomery bus boycott illustrates this topology. Rosa Parks' arrest activated her extensive network of strong ties, who launched the boycott through localized, high-trust social groups. Civil rights leaders like Martin Luther King Jr. sustained the movement by leveraging weak ties. By framing the boycott as a community habit enforced across disparate social clusters, they created a unified front that could endure for over a year. This model also explains the massive expansion of Saddleback Church. Saddleback engineered growth by building initial strong-tie small groups in living rooms. They then transitioned these members into sprawling, weak-tie community habits, linking thousands of people into a single social web. Ideology alone cannot fuel societal change. The process requires the mechanical propagation of habits across specific social networks. Neurons, organizations, and societies are all governed by the same underlying drive for energy-saving automaticity. This raises a question regarding the neurology of free will. If our actions are the output of automatic loops, to what degree are we responsible for them? Measured agency begins with mechanical comprehension. Understanding a loop structure provides the ethical responsibility to alter it. This diagnostic framework allows anyone to reverse engineer a habit at any scale. Step 1 is identifying the routine behavior. Step 2 involves experimenting with different rewards to isolate the true underlying craving. Step 3 is isolating the exact cue by cutting through environmental noise. Most triggers are tied to a specific time, location, emotional state, person, or preceding action. Step 4 is formulating the new plan. Once the cue and reward are isolated, you deliberately insert a specific, novel routine into the loop. Whether the goal is restructuring a Fortune 500 firm or organizing a social movement, behavior is malleable. You gain control of the system once you identify the gears of the loop.